Well, hi everybody, it's Greg and I'm back again with some results. I've done some testing with different battery configurations that you can use with the Zoom F8 audio recorder. And because it uses the Hirose connector for a lot of these tests, same as the F4 audio recorder, you can apply a lot of these things to the F4. Your results will vary, however, because it's two different recorders. In fact, Zoom has already published how long they say the Zoom recorder will run based on different configurations with different batteries. So, for example, you can run this with just recording one channel of audio, or all 8 channels of audio, or any combination of those 8 channels. You could have phantom power going to just one channel, or all 8 channels, or any combination of channels. So there's a lot of variables there, because as you record to more channels and you record with more phantom power to more channels, that's going to decrease the amount of battery life you're going to get before you need to change batteries. So also, you could be recording at lower or higher bit rates, sampling rates, I should say, bit depth. You could record 16-bit or 24-bit, and you can record from 44.1K as your sampling rate all the way up to 192. So those things will also affect the battery life. So in order to kind of do a consistent baseline for all of these tests that I've run, I was recording to 6 channels of audio at 48K 24-bit. And out of those 6 channels of audio, I was feeding phantom power to 4 of them with these Rode microphones, and I was just going with dynamic microphones on the other 2. So 4 with phantom power, 2 without. 6 channels recording altogether. That's how I did it to be consistent with all of these tests. So let's give you some results. Now in the last video, I put together this battery pack, which holds 8 D-sized batteries. I thought, well, what can we do with 8 D-sized batteries running in through the Hirose connector? And I just used these budget D-size batteries, alkaline batteries that I picked up. And it ran for 9.5 hours. 9.5 hours before the Zoom recorder had drained it enough that it just had to shut down, or at least switch to the internal battery pack. So, well, that's pretty good. That's not quite a full day of shooting on most movie projects, but 9.5 hours, that'll give you enough time to swap other battery packs out. And I still think maybe you could just use these, and every 2 or 3 hours you could swap these out while using this as your power source during the swapping. I don't know, it's up to you. Now, one of the phenomenon of alkaline batteries, however, you put a constant load on them, and they drain until you can't use them anymore. Then you put them aside for a few days, and suddenly it looks like they've got their second wind. They've come back to life somehow. So that's what I experienced with these batteries. So I went ahead and loaded them up again and tried to run the Zoom recorder again after, again, a few days of rest. And they went for another hour and a half before they were just drained enough that they couldn't do it anymore. So I guess that's a total of 11 hours. You wouldn't want to rely on these already spent batteries and say, oh, I think I can get another hour and a half out of them. But whatever, you've got that going on. So when it comes to alkaline batteries, of course, Zoom has already said, they've made some comparisons themselves, different recording configurations using alkaline batteries, or rechargeable nickel metal hydride batteries, or non-rechargeable lithium batteries for their tests. They were comparing. Now, I have a lot of these Eneloop rechargeable batteries, so I have an awful lot of these kind of standard capacity Eneloop batteries. For the rechargeable battery tests that Zoom did, or the results they published, they were using the higher capacity batteries like these Eneloop Pro batteries. So like anything online, your results may vary, your mileage may vary, as they say. And then, you've got these nifty lithium AA batteries that tend to do really well with high drain devices. So according to Zoom, your alkaline batteries if you're just using the internal battery pack that slides inside the Zoom recorder. If you're using alkaline batteries, you do pretty well. If you're using rechargeable nickel metal hydride Eneloop Pro style high capacity batteries, you're going to do even better. And the best results they report are using these non-rechargeable lithium batteries. I tend to avoid these only because they're very expensive in comparison to the other options. And I don't really need the advantages that are offered if I have enough of these rechargeable batteries and just enough time to swap them out from time to time. But if that's what you prefer, go for it. Lithium batteries, it's a great technology. It's just kind of expensive. So, all right. I did my alkaline test with D batteries and 9.5 hours. And I should mention there's another variable in here. I turn on the Zoom recorder and I just let it run. And very minimal monkeying around with it while it was running. I occasionally would just turn some knobs and check what the battery meter was saying and a few things like that. But I just left it recording continuously for that long duration test. If your screen is set to a higher brightness or a lower brightness, that's going to affect battery power. When you're stopping and starting recordings and doing other things on the menu, that's going to probably drain more battery power than if you just let it run and you're not touching it. So I said 9.5 hours with this battery pack. In normal usage, it would probably be lower than that because you would probably be starting and stopping more often than I did. So that's just something to consider. But I thought just to be sure, I should take the same brand of alkaline battery and try the AA version and see how long it would run. Again, same test, same parameters. I went for about 2 hours and 15 minutes before they were just drained and wouldn't work anymore. And when I tried, wait a few days and put the same batteries in and try it again, for the AA alkaline batteries, it only gave me less than a minute of its second wind. So that's going to be your poorest results. However, they're probably your cheaper battery, disposable, easiest to get to alkaline AA. Okay, the next test I decided to try, using this D battery adapter that I had that could hold 8 D batteries. What if instead of 8 D batteries, I used an adapter that would substitute 2 AA batteries in place of a D battery? So I did it that way, filled up 8 of these adapters for a total of 16 AA batteries, and then I ran the test again with this, and it was these Eneloop, the regular Eneloop rechargeable batteries. I got 5 hours and 15 minutes of useful time with the 2 AA batteries substituting for each of the alkaline D batteries. So if you have again, that's 16 batteries. So if you've got 32 batteries and you can swap them in the middle of the day, that takes you to almost a full day. That's 10.5 hours if you did it that way. Then I thought, well, okay, I just got some of these. This is a little adapter that will allow you to put 3 AA batteries in place of a D battery. And so I filled up 8 of these with a total of 24 rechargeable Eneloop batteries, and I got 7 hours and 45 minutes of use out of that. So if you had, again, 48 rechargeable Eneloop batteries with these adapters, now you're up to, 15.5 hours of continuous use. So there you go. Now, you'll need a good battery charger and maybe multiple battery chargers to keep up with that, but that's an option. Okay. Now I also decided, just to be thorough, I would actually run an endurance test with one of these guys. This is a jump starter battery that you would usually use for a car if you got a dead battery in your car. I put a little meter on there. So this is a 12 volt, made for 12 volt systems, and when it's fully charged, it's a little bit higher than 12 volts, and you can drain it down to, safely down to maybe 11 volts before you really should recharge it for the sake of this battery. So I tried it. I put the car socket adapter in here that just went out to the same DC adapter I needed for my Hirose connector, and so I had the 12 volts or just a little bit higher when I started out to run this test, and of course this kept going and going and going and going, and just very slowly draining, because it's a nice good capacity battery in there. I think it's like 17 milliamp or amp hours is the rating on this one. And the result I got was that, yes, the battery did drain over several hours, but it did not drain so much that it could not safely run the Zoom recorder without damaging the battery. And this ran for about 20.5 hours until I actually filled up the memory card on here. And that's why it stopped. Not because this battery gave out, but because the memory card was full, and I thought, okay, that's good enough. If you can't manage with 20.5 hours of power before you come up with something else to plug in, then I don't know how much I can help you after that. So those are just some of the variables I did relatively cheaply with batteries that I already had them, or I've just made a cheap little adapter. Again, using AA and D batteries and the big old jump starter battery for the car. Now, I guess my conclusion after all this is that I still come back to what I started with, and that is using a video camera battery to run the F8 is kind of my favorite thing to do. And why is that? Well, because that's a pretty easy thing to manage. It's just this right here. The video cameras I'm using now to make this recording, like other Sony cameras I got, they come with a battery that will run the thing for an hour, maybe an hour and a half if you're lucky. And that's the standard battery that comes with the camera. So if you're going to buy a spare battery for the camera, which of course you're going to need that if you're doing anything professional, you're usually going to get a higher capacity battery, the one that you're going to buy, and you're not going to have a lot of use for this low capacity battery that came with the camera. And in this case, you could also get an even higher capacity battery that goes with your Sony camcorder. So what I run into when I use these camcorders is I have these batteries. Sure, I like using these batteries. These ones that came with the camera, I don't really like to use them because it just seems like I turn it on, I get everything set up, and by the time I'm really getting into my project, the battery's already kind of running out. So what do I do with these? Well, I found a great thing to do with these, and that is to run the Zoom F8 audio recorder. One of these batteries put in this little adapter that I saw, and this is the first video I made about the F8 audio recorder, is when I was showing off how you could get this adapter, and then you could use this with a Hirose cable adapter to run the F8. And this I was able to run for, this middle capacity battery that I had was able to run, I think I said it was over 9 hours doing it this way. And this one here, the one that came with the camera that I think is kind of a low capacity battery and not real practical for my video work, this one will run the F8 for about 5.5 hours. So between these two things, which I already had, which I don't like to use that much, there's your 11 hours right there with these two batteries. And look how easy they are to manage. There's not, 8 batteries to manage. It's just one battery that just snaps onto this thing and comes off. And so this is still my original idea. Could I run the F8 with video camera batteries? That is still my favorite option to try. And just to be thorough, since I had already tested this middle capacity battery in my first video, I decided to run a test with this highest capacity battery. This is made for a video camera, but using this adapter here, how long would it run, doing my same parameters, and I came out with, 12 hours and 45 minutes before this battery was drained so much that I thought, okay, gotta stop. This battery, when it's fully charged, is about 16 volts, And when it starts to get very low, is down around 14 volts, even though the battery is rated for 14.4. So I was getting it down below 14 volts and thinking that I was getting a little dangerous for the battery to be drained that much. But this right here is a third-party battery. It ran for 12 hours and 45 minutes. And these batteries, let's see, I mean, if you look at it, it's rated for, this small one here, 1850 milliamp hours, 1850. This middle capacity battery is rated for 4600 milliamp hours, and this one is rated for 6600 milliamp hours, which isn't even the highest capacity available in these third-party batteries, or even the Sony name brand equivalent of this battery actually has a higher capacity than that. So if you had one of those other high capacity video camera batteries, you'd probably get more than 12 hours and 45 minutes. So, all right, that's those are real world results, though. I didn't want to leave you wondering, well, what if you tried this? What if you tried that? I've tried everything, and I've tested this, and I let it run for hours and hours and days, and this is what I came up with. And I still like these other battery options, and I'm going to keep these and know that I can use them. But in the long run, I really think this is my favorite thing to do for kind of a non-traditional external battery option for the Zoom F8, and you can use it again also for the Zoom F4 audio recorder. Get yourself a Hirose cable adapter, and you're in business. Thanks for watching.